Okay, so we're going to get started with our next lesson, which is lesson 6.5, multiplying polynomials. So here's a warm-up for you guys to try. It's just to get your minds refreshed on some of the skills. But what you guys are going to be able to do today is multiply polynomials. And like always, guys, the note sheet is posted on Schoology for you guys to print out, follow along with, whatever you want to do to take your notes. But we're just going to look at the first half. So you guys aren't going to use your full guided notes today. You're only going to be using half of it. Just because I think it's important for you guys to understand the foundation before we move on to the next part. So what we're going to start out with is to multiply polynomials and monomials. So remember, monomials are one term, whereas polynomials could be any number of terms. Okay, and you'll use some of the properties of exponents that we have learned earlier. But we're simply going to be multiplying a monomial with a polynomial. So remember to keep in mind that when you have the same bases, you simply just add your exponents together to get what your power will be for your base. So here we go, multiplying monomials. So with the first one here, you have 6y cubed times 3y to the fifth. We're just going to group it first so then you guys can see how this is done. So I'm just going to group the coefficients first. So I'm going to take 6 times 3. And then I'm going to group my variable terms. So I have y cubed times a y to the fifth. Okay? And now you're just going to worry about simplifying this. So 6 times 3, you would multiply together to get 18. Now you have y cubed times y to the fifth, so you add those exponents together, so you get y to the eighth. So when you're working with these, you multiply the coefficients together, and then you simply just add the exponents together. So looking at this next one here, again, we're going to group it. So you have 3mn squared times 9m squared n. So I'm going to group my coefficients of 3 times 9. Now I have variable terms, so I have two variables here. So I'm going to group my first variable, which is m times m squared. And then I'm going to do my n. So I have n squared times n. And now multiplying together, 3 times 9 is 27. M times m squared is m. Remember, this is to the first, so m cubed. And then n squared times n would become n cubed. So when I multiply 3mn squared times 9m squared n, I get 27m cubed n cubed. Okay, so you just multiply coefficients, add the exponents of the bases that are the same. Oh my goodness, a fraction. Guys, it's the same concept, okay? I know you all just groaned as soon as you saw this problem. So I'm just going to group the coefficients. So I have 1/4. This has a coefficient. Remember, if it doesn't have 1, you give it 1. So it's just 1. And then you have this -12. So times -12. Now I'm going to group my s's. So I have s squared times s times another s. And then I have my t's. So I have t squared times t times another t squared. Okay? Now remember, you can take any whole number and write it over 1. Well, if you multiply straight across, you get -12 over 4. Or if you're like me and you simplify along the diagonal, I have 4 and -12. So 4 goes into -12 and -3 times. 1 times -3 is -3. 1 times 1 is 1. So this now becomes -3. Adding all of these together now for s. So 2, 1, and 1 gives me 4. So this becomes s to the fourth. And again, over here, that would give me t to the fifth. And there's your final answer when you multiply. So right now, what I would like for you guys to do is pause the video, and then you guys are going to try the 3 you try. Once you hit play again, you'll be able to see the answers to the next few problems. So pause the video right now and try. There's one more on the next slide as well. Okay, so here's this set of answers for you guys. If you notice, starting at this problem here, I didn't write out the full expansion, and that's okay. As you guys start to do these, you guys are going to start to see, but I wanted to at least show you guys that you can do it in the expanded form, or if you're at the point right now that you can do this, you can. I'm just going to tell you guys, please be careful when you're doing the multiplication. So then hit the next slide so then you can see the next one. All right, and here's the answer for letter C. All right, if you guys have questions, please contact me. But what we're going to do now, so that was multiplying a monomial by a polynomial. That was just multiplying monomials together. So now what we're going to do is we're going to look to multiply a polynomial and a monomial. So in this case now, you need to use the distributive property. Now make sure when you use the distributive property now, you take that term to everything inside the parentheses, okay? A lot of you tend to forget to take it to everything, okay? So make sure that you take it to everything. So looking at this, multiply a polynomial by a monomial, you're going to multiply 4 times 3x squared plus 4x minus 8. So we're simply just going to distribute the 4. So you're taking 4 times 3x squared. So that becomes 12x squared. 4 times 4x. So that gives us 16x. And then 4 times negative 8, which is negative 32. And that right there is your product from multiplying the monomial by the polynomial. So really, this is a skill you guys have known, but before, instead of doing 2 terms, or 3 terms, you've just been working with 2. So let's look at this one now. Multiplying a polynomial by a monomial. So you're still going to distribute, and you're distributing in this whole term here of 6pq. So this goes to here. So this is just doing what we are just doing at the start. So you're going to multiply the coefficients. So if you need to at this step to break it down for yourself, you can. So if you want to do it as 6 times 2, and then you have p times p, and then you still have q. Now you're subtracting that with, when you multiply this together now, so you have 6 times p times q times q. Okay, so if you need to write it out like that, you can. Otherwise, you could just do the distributing here. So this becomes 12p squared q minus 6p q squared. So whether you take it and you distribute and you go right to this step, or you take it and you break it down and you go from here then down to here, it doesn't matter. Do whatever you are most comfortable with. So we're going to look at one more example, and I'm ready for all the groans. But fractions are still just as easy as it is with the whole numbers. And again, guys, remember, if I'm going too fast going through the PowerPoint, you can always pause too. So you're going to take 1/2 x squared times this 6xy. So with this, yeah, you can break it down into each step too, but you're taking half of 6. So really it's like saying 6 divided by 2. So fraction form, you could go that way. In my eyes, that's easy for me, but I'm going to break it down for you guys just because I think visually seeing it for some of you is important. 6/1. Then you have this x squared times x. And then you have y times y. Plus, now you got to do this next one. So now you have plus 1/2 times 8/1. X squared times x squared. And then you have y times squared. I'm running out of room. Parentheses, make it okay. So 1/2 times 6 over 1 gives you 3. X squared times x gives you x cubed. Y times y is y squared. Plus 1/2 times 8 is 4. X squared and x squared is x to the 4th. Y times y squared is y cubed. Now, I didn't ask you this with any of the other examples, but would you be able to combine any of the like terms or any terms in here? Take a minute, think about it. If you said no, then you are correct, because these are not like terms, and the reason being is because your x terms are raised to different exponents for both x and y, okay? So you cannot combine any like terms, so this right here would be your final answer. So I'm going to ask that you guys pause the video and you guys try the U-tries. You do have 3 of them that I want for you guys to try. So take a minute right now, pause the video, and try the problems. Okay, here's your example for the first one. So 2 times 4x squared plus x plus 3 gives us 8x squared plus 2x plus 6. Letter B, you get an answer of 15a cubed b plus 3ab squared. One more to do. And the last one, letter C, gives us 5r cubed s squared minus 15r squared s cubed. Alright, so that's the end of the examples for taking a monomial and multiplying with a polynomial. What we're going to do right now is get into this next part, which is multiplying a binomial by a binomial. Now remember, a binomial has how many terms? 2. Good. So it has 2 terms. So you're taking 2 terms times 2 terms. So what we're going to look at right now is this example, okay? And it's in your notes for you guys. So you guys need to know that you're applying the distributive property more than once, okay? So you're going to be actually applying this 2 times. So in order for you guys to see that, what I'm going to be doing is I'm going to be breaking down this first binomial, okay? And we're going to break it down into 2 separate terms. So you have your x term, so that x term needs to get multiplied with this second polynomial here. So this now is going to become x times x plus 2. Now you have to take this second term in the first binomial, and you still need to distribute it to this binomial. So you apply the distributive property once here, and then the second time here, with taking these 2 terms and separating them. So now what you got to do is what we know to do, and that's distribute. Okay, so we're just going to simplify these by distributing. Now, if you notice, you have some like terms here. So in this case now, we're going to combine those like terms. So you get x squared plus 5x plus 6. Okay, so multiplying 2 binomials together, you need to make sure that you apply the distributive property twice. Now, this is where the fun gets into play. So this is probably like my favorite part of Algebra 1. It's the one thing that I loved as a student, and I love teaching it as well. But I'm going to teach you the next method. And we call this the FOIL method. And it's an excellent way for remembering how to multiply binomials together. So FOIL is an acronym that we use. And what it simply stands for is you multiply the first terms. So what that means is these first terms in each binomial you multiply together. Then you multiply your outer terms. So that means the 2 on the outermost sides of both binomials. Then you multiply your inner terms. So what that means is you have your innermost terms in each one. Okay, so they're the ones right next to each other. And then finally, you multiply the last terms. Okay, so they're the last term in each binomial. And if you notice, this is using the same example that we had before. So if you notice x squared is equal, and then the 2x, 3x, and 6, if I go back, that's exactly what we had at this step. So if we do this together right now. Okay, so let's look at showing FOIL when you're given the 2 binomials. So you go x times x because that's the first terms. That gives you x squared. Now you do your outer, so that's the outside terms. X times 2, 2x. Inner, inside most terms, 3 times x, 3x. And then your last terms, 3 times 2, which gives us 6. Okay, combining like terms, you get x squared plus 5x plus 6. Okay, and that is using the FOIL method. Now, there's another method called the box method. And this is kind of like Punnett squares when you guys did that in science. But what you simply do is you take one of your binomials and you write it across the top. And then you take the other one and you write it going down the side. And then you multiply a row by the column. Okay, and then you combine like terms along the diagonal. So let's just do it versus listening to me. So I'm going to take the first one and write it across the top and take the sign with the number. Okay, and then you have x plus 2, and I'm going to write that down the side. So now how you would do it is you would multiply these two together to get this box here. So x times x gives us x squared. So now I would multiply x and positive 2 for this box right here. And in that case, you get 2x. This box right here, I multiply 3 times x to get 3x. And in this last box here, I multiply 3 and 2 to get 6. Now, how I say combine like terms along the diagonal, if you guys notice, along here, that is where your like terms fall. Okay, so that's why you're going to combine those terms, and that gives you x squared plus 5x plus 6. So this one is really good if you're more of a visual person. I am going to let you guys know that you are going to need to know how to use FOIL, but if the box method is something that works for you, you're more than welcome to use it. So right now, what we're going to do is we're going to go through some examples. I'm going to go through mainly using the FOIL method for 2 of them, but I'll use the box method for 1 of them as well. So here we go. So multiplying the binomials together, s plus 4 times s minus 2. So if it helps, write FOIL up at the top so you know what to do. So you got to do the first terms. So first one in each spot. I'm going to write f. So s times s gives me s squared. Now I have to do the outer. S times negative 2. So that's the outer. Gives me negative 2s. Now I have to do my inner. So that's the innermost term. So that's 4 and s. So that gives me positive 4s. And then last but not least, I have to do my last terms, which is 4 times negative 2, which is negative 8. Okay, and then remember, the next step is to combine any like terms and then simplify to get your final answers. So this becomes s squared plus 2s minus 8. Okay? So now, when you multiply 2 binomials together, if you notice, you end up getting a trinomial. All right, let's look at the next example. Now, this kind of looks a little different. So you have x minus 4 all raised to the second power. You're not going to take this exponent and distribute, okay? And the reason being is because in this case, that is not how this one is solved. I want you guys to take a moment and think. If I were to just tell you x squared, how many of those x's do you really have? If you told me 2, you're correct, because x squared is the same thing as saying x times x. So if I gave you x minus 4 quantity squared, that's telling you how many of those x minus 4s that you're going to have. Remember, think back to this of x squared. So if you just said to yourself that you're going to have 2 of them, you're correct. So I'm just going to rewrite it now to show that. So this is really like saying x minus 4 times x minus 4. And then all I got to do now is follow FOIL. So first, x times x, which gives me x squared. My outers, so the outermost, x times a negative 4, negative 4x. Inner, negative 4 times x is negative 4x. And then my last, negative 4 times negative 4, positive 16. Combine like terms. You get x squared minus 8x plus 16. And that's your final answer. Okay, so if you ever see it written where you have a binomial raised to the second power, just know that you have 2 of that binomial, really. Okay, and it's good to write it out. All right, so I've done 2 with FOIL now. This last one here I'm going to do using the box method. So I'm going to draw myself a box. And remember, the first one, it can go either across the top or down the side. I'm just going to put it across the top. The sign goes with that second term. And then this last one, I'm going to put down the side. And then you just simply multiply the 2 numbers together, row and the column. So 8m squared times m squared gives me 8m to the 4th. 8m squared times negative 3n gives me negative 24m squared n. Okay, because you're multiplying those terms together. M squared times negative n is just negative m squared n. And then if I take negative 3n times negative n, that gives me a positive 3n squared. Now, going along the diagonal, combine your like terms. So I'm going to rewrite this to be 8m to the 4th minus 25m squared n plus 3n squared. And that's your final answer. That is the product to your 2 binomials. Just so you guys kind of are aware, but in this box, if you notice, I said that you should take m squared times negative n, but most of the times I started up top when I was multiplying. Just know that we write in alphabetical order with our variables. I'm also going to tell you this. Negative n m squared is the same thing as saying negative m squared n. Okay, one's just in alphabetical order, the other one's not. And if you notice in my final answer, typically how we would write it is in standard form with the highest exponent down to the lowest. But what you want is your variable term that comes first in the alphabet. Then you have this middle term here that contains both variables followed by the variable that's the furthest in the alphabet. All right. Now, pause the video and try the 3 you try. All right, here's your first example. Your second example. And finally, your last example. Now, if you guys notice in this one here, if you were going in this order, most of you probably wrote negative b squared a. Again, guys, that's the same thing as saying negative a b squared. I'm just writing it in this order, though, because that's how I originally wrote it with that first term that I did. Okay, so just kind of keep that in mind. All right, so that's the end of the first half of the lesson. And that's where we're going to stop today because I want to practice with you guys a little bit more. So what I'm going to ask that you guys do, and I'm not going to give you any additional work to try these with, but next class we're going to work more with the FOIL method. Right now, all I want for you guys to do is complete the exit ticket that I have posted for you guys to just answer a simple question. We're going to spend the next day of push out, so Thursday, on working with the FOIL method more, okay? So if you have any questions, please make sure you attend my office hour. You can send me messages, whatever you want to do. But right now, I just want you guys to take a breather. I know it was a lot today, but you guys did awesome. So if you have questions, please contact me. Other than that, have a great day, guys.